Today we are going to discuss a new topic, ionic equilibrium. So ionic equilibrium first, electrolytes. What are electrolytes? Which conduct electricity are called electrolytes. Okay, electrolytes two types. Electrolytes two types. One is strong electrolytes, and the second one is weak electrolytes. So electrolytes are two types. One is strong electrolytes and second one is weak electrolytes. One is strong electrolytes and second one is weak electrolytes. Okay, strong acids like HCl, HClO4, HNO3. Similarly, strong bases like NaOH, KOH. Similarly, salts, NaCl aqua, AlCl3 aqua are strong electrolytes. Okay, are strong electrolytes. Okay, speed ga రాయండి. Okay, strong electrolytes are completely ionized. Strong electrolytes are completely ionized. And the second one is they have highly conducting nature. Highly conducting nature. Degree of dissociation is equal to degree of dissociation is denoted by alpha. Alpha is equal to 1. Degree of dissociation, alpha is equal to 1. So for example, NaCl aqua gives rise to, this is strong electrolyte, Na plus aqua plus Cl minus aqua. Okay, this is strong electrolyte. HCl aqua gives rise to, this is strong electrolyte. H plus aqua plus Cl minus aqua. Okay. Next, sodium hydroxide aqua NaOH aqua gives rise to Na plus aqua, Na plus aqua plus OH minus aqua. So these are the strong electrolytes. Okay. Next, weak electrolytes. Weak acids, weak acids, weak acids like acetic acid, hydrogen cyanide, hydrogen cyanide. Next, weak bases like ammonium hydroxide are weak electrolytes, They have less conducting nature. Okay, degree of dissociation. Alpha less than 1. Okay, they do not completely ionized. They do not completely ionize. But at infinity dilution, alpha is equal to 1. Degree of dissociation is equal to 1. Alpha is equal to 1. Degree of dissociation is equal to 1 at infinite dilution. ఓకే, వీటిని మనం వీటిని వీక్ ఎలక్ట్రోలైట్స్ అంటాం. స్ట్రాంగ్ ఎలక్ట్రోలైట్స్ కంప్లీట్లీ అయనైజ్ అవుతాయి. వీక్ ఎలక్ట్రోలైట్స్ కంప్లీట్గా అయనైజ్ చేసుకోవు. స్ట్రాంగ్ ఎలక్ట్రోలైట్స్ ఆర్ గుడ్ కండక్టర్స్, వీక్ ఎలక్ట్రోలైట్స్ ఆర్ పూర్ కండక్టర్స్. ఓకే, నెక్స్ట్ నాన్ ఎలక్ట్రోలైట్స్. These are bad conductors, not ionize. Okay, example, glucose, urea, sucrose. These are non-electrolytes. Water soluble. The glucose soluble in water, but these do not produce any ions. Glucose soluble in water, but glucose does not produce any ions since it is covalent compound. So aqueous solution of glucose is bad conductor of electricity. Aqueous solution of glucose is bad conductor of electricity. Aqueous solution of glucose is bad conductor of electricity. Okay, Completed. Next, these are non-electrolytes. What are that? Glucose, urea, and sucrose. Sucrose. These are soluble in water. They do not produce any ions. So, aqueous solution of glucose is bad conductor of electricity. Okay. Next, Arrhenius theory of dissociation. Next, Arrhenius theory of dissociation. Arrhenius theory of dissociation. Arrhenius theory of dissociation. For example, an electrolyte AB aqua gives rise to A plus aqua plus B minus aqua. AB aqua gives rise to A plus aqua minus B minus aqua. Please write down. AB aqua gives rise to A plus aqua plus B minus aqua. The initial concentration C 0, 0. At time is equal to T. Degree of dissociation alpha. What is degree of dissociation? Degree of dissociation is denoted by alpha. Okay, moles dissociated by moles taken is called degree of dissociation. Degree of dissociation దేంతో ఇండికేట్ చేసాం చెప్పు ఆల్ఫా. దేంతో ఇండికేట్ చేసాం ఆల్ఫా. ఓకేనా, ఆల్ఫా రావాలి అంటే ఏం చేయాలి చెప్పండి, సి మైనస్ సి ఆల్ఫా. దిస్ ఈజ్ మోల్స్ డిసోసియేటెడ్ సి ఆల్ఫా. సి ఆల్ఫా బై సి, సి క్యాన్సల్ అయితే వస్తుంది ఆల్ఫాయేగా. ఓకేనా, సో డిగ్రీ ఆఫ్ డిసోసియేషన్ ఆల్ఫా. ఓకే, దేర్ ఫర్ సి మైనస్ సి ఆల్ఫా. దేర్ ఫర్ సి ఆల్ఫా బై సి, సి క్యాన్సల్ చేస్తే ఏమొస్తుంది ఆల్ఫా వస్తుంది. వాట్ ఈస్ డిగ్రీ ఆఫ్ డిసోసియేషన్? మోల్స్ డిసోసియేటెడ్ బై మోల్స్ టేకెన్. So this is C alpha. Therefore K is equal to constant, equilibrium constant. K is equal to, according to law of mass action, K is equal to concentration of A plus into concentration of B minus divided by concentration of AB. Therefore K is equal to C alpha into C alpha divided by C into 1 minus alpha. Therefore K is equal to C alpha square divided by 1 minus alpha. This is the expression. C square, C cancel kada. This is not C, this is a bracket. C square alpha square divided by C alpha square divided by 1 minus alpha. So alpha is degree of dissociation. Okay. Factors affecting alpha. Degree of dissociation depends upon which factors? Next, factors affecting alpha. Factors affecting alpha. Okay, first one, nature of electrolytes. Nature of electrolyte. For strong electrolytes, alpha is equal to 1. For weak electrolytes, alpha less than 1. Strong electrolytes ante they are completely ionized. Weak electrolytes ante they do not completely ionize. Okay, for strong electrolytes alpha is equal to 1. For weak electrolytes alpha less than 1. And the second factor, nature of solvent. Is the first one. And the second factor, nature of solvent. Nature of solvent. Okay, nature of solvent. Solvent with a high dielectric constant. Solvent with a high dielectric constant. High dielectric constant. High dielectric constant. Okay, can dissociate electrolyte completely. Curd solvent with high dielectric constant can dissociate electrolyte completely. ఒక ఎలక్ట్రోలైట్ కంప్లీట్గా డిసోసియేషన్ జరగాలి అంటే సాల్వెంట్కి ఏమి ఉండాలి? హై డైఎలక్ట్రిక్ కాన్స్టెంట్ ఉండాలి. హై డైఎలక్ట్రిక్ కాన్స్టెంట్ ఉండాలి. Solvent with a high dielectric constant can dissociate electrolyte completely. So in the presence of solvents, electrolytes are dissociated. Okay, solvent with a high dielectric constant can dissociate electrolyte completely. For example, water NaCl dissociate చేస్తుంది. NaCl వాటర్లో వేస్తే ఏమవుతుంది? Na ప్లస్ Cl మైనస్. అదే NaCl బెంజిన్లో వేస్తే డిసోసియేషన్ జరగదు. ఎందుకంటే వాటర్కి డైఎలక్ట్రిక్ కాన్స్టెంట్ ఎక్కువగా ఉంది, బెంజిన్కి డైఎలక్ట్రిక్ కాన్స్టెంట్ తక్కువగా ఉంది. ఓకేనా? నెక్స్ట్ థర్డ్ ఫ్యాక్టర్, కాన్సన్ట్రేషన్ ఆఫ్ సొల్యూషన్. థర్డ్ వన్, concentration of solution. And fourth one, temperature. Degree of dissociation alpha is directly proportional to temperature. Directly proportional to temperature. Degree of dissociation is directly proportional to temperature. Okay, next MSET important. Next is the common ion effect. Okay, what is common ion effect? For example, acetic acid CH3COOH gives rise to CH3COO minus plus H plus. When strong electrolyte is added, HCl is added. ఇక్కడ ఏముంది? ఇక్కడ what is this? H plus ion. HCl has H plus ion. So here common ion is H plus. What happens when H is a strong electrolyte, HCl is added? Okay, dissociation of acetic acid decreases. So alpha decreases. Okay, now this is called common ion effect. What is this? Common ion effect. This is very very important. MSET లో అడుగుతారు, ఇది జాగ్రత్త చూసుకోండి. నెక్స్ట్, Ostwald dilution law. Ostwald's dilution law. Okay, take an electrolyte AB. AB aqua gives rise to AB aqueous gives rise to A plus aqua, B minus aqua. Concentration C 0 0. Okay, degree of dissociation C alpha, C alpha, C alpha. What is degree of dissociation? I already told you. What is degree of dissociation? Moles dissociated divided by moles taken. Moles dissociated by moles taken. Okay. Therefore, apply law of mass action. K is equal to concentration of A plus concentration of B minus divided by concentration of AB. Therefore, K is equal to C square alpha square divided by C into 1 minus alpha. Therefore, K is equal to C alpha square divided by 1 minus alpha. K is equal to C alpha square divided by 1 minus alpha. Okay. Okay. Right. This is weak electrolyte. For suppose this is weak electrolyte. Neglect alpha. Neglect alpha. For weak electrolytes, neglect alpha. For weak electrolytes. For weak electrolytes. What happens? K is equal to C alpha square. Alpha is equal to root K by C. Alpha is equal to root K by C. Alpha is equal to root K by C. Okay, you understand this? Alpha is equal to root K by C. Alpha is equal to root K by C. Okay. Alpha is equal to root K by C. But C, concentration is equal to, concentration is equal to moles per liter. When N is equal to 1 mole, concentration is equal to 1 by V. Substitute here, alpha is equal to, K into V. Therefore, when dilution increases, alpha increases. V ante volume. When volume increases and dilution, V increases. So alpha increases. Okay. It is important. So when a dilution increases, alpha increases. What is alpha? Degree of dissociation. What is alpha? Degree of dissociation. Okay. Please see this equation. K is equal to C alpha square divided by 1 minus alpha. K is equal to C alpha square divided by 1 minus alpha. C alpha square K into K alpha. Yes or no? Yes or no? C alpha square is equal to K into K alpha. Okay. At infinite dilution, V maximum. When V infinity, C is equal to 0. Why? When V is equal to infinity, 1 by infinity, 0. Therefore, C is equal to 0. C alpha square is equal to 0. Therefore, K minus K alpha is equal to 0. Alpha is equal to 1. So, at infinite dilution, alpha is equal to 1. At infinite dilution, alpha is equal to 1. Okay. At infinite dilution, alpha is equal to 1. Right? Completed? Okay. Alright. Note. A weak electrolyte starts behaving. A weak electrolyte starts behaving like strong electrolyte, behaving like strong electrolyte when solution is highly diluted. When solution is highly diluted. When solution is highly diluted. So it is called infinitely dilution. It is called infinitely diluted solution. It is called infinitely diluted solution. Okay. Such solution has maximum conductivity. Such solution has maximum conductivity. Such a solution has maximum conductivity. Okay, understand this. Okay, please cross check one time. Okay, next. Arrhenius acid-base theory. Arrhenius acid-base theory. Acid-base theory. Arrhenius acid-base theory. What is Arrhenius acid-base theory? Arrhenius acid. It produces H plus ion in aqueous solution. Example, HCl gives rise to H plus aqua, Cl minus aqua. H2SO4 gives rise to H plus aqua, HSO4 minus aqua. Okay, HNO3 gives rise to H plus plus NO3 minus. HCN gives rise to H plus plus Cn minus. HNO2 gives rise to H plus plus NO2 minus. These are weak electrolytes. So these are acids. What is Arrhenius acid? Acid is a substance that produces H plus ion in aqueous solution is called Arrhenius acid. Okay, Arrhenius base. Have you completed? Okay, Arrhenius base. What is Arrhenius base? Substance. Arrhenius base. Substance which produces produces OH minus ion in aqueous solution. In aqueous solution. Example, NaOH. Sodium hydroxide gives rise to Na plus plus OH minus. Okay, KOH gives rise to K plus plus OH minus. NH4OH gives rise to NH4 plus plus OH minus. But Arrhenius theory could not explain acidic nature of some substances and basic nature of some substances. That's why this theory was discarded. Arrhenius theory could not explain acidic nature of CO2, SO2, SO3, basic nature of NH3, basic nature of NH3. That's why this theory was discarded. Okay.